In this tutorial, we are going to discuss SIP trunk configuration for a SIP trunk that connects to BTC, which is Botswana Telecommunications Corporation. It is strictly specific to BTC. So this lesson is just meant to be theoretical. We are just going to discuss in theory. Then in the next video, that's when we will do practical. That's when we will get onto the Mivoice business and then actually get to configure a SIP trunk. But for now, we are just discussing, we are just talking and talking. So we need to grasp the principles or the concepts first before we can think of getting onto the controller and configuring. So I've got here with me an architecture, a diagram of what the connection will look like when we are actually configuring a SIP trunk. So we are going to have my voice business controller here, which is this one, and it's going to be having an IP address of 192.168.1.2, and it's connected to the LAN where we've got 3 Mitel IP phones with IP address of .5, .6 and .7, and then this LAN connects to a firewall with the default gateway or the interface on the firewall that is connecting into the LAN having an IP address of 192.168.1.254. The firewall has an internet connection on another interface which has a public IP address of 202.101.40.conf. This IP address is fictitious. It doesn't exist. I just picked it at random for the sake of this demonstration. It's not an IP that belongs to me, or it could, if it belongs to you, it's by coincidence. And from the internet, we then connect to our BTC side, which is the BTC SIP trunk. And on the BTC side, there is signaling, which has its own public IP address, which is 186.176.45.23. Again, this is not the IP address that BTC uses. It's fictitious. I didn't want to use the actual IP address in this tutorial, so I've just created a fictitious public IP address, but it gets the job done. You still understand what it is that we need to achieve. And also on the BTC side, there is also a media. So the SBC has got a signaling IP address and a media IP address. Their media IP address is 186.176.45.22. So effectively what we are going to have is the SIP trunk being a peer-to-peer connection. The SIP trunk is going to be a peer-to-peer connection between BTC's public IP address, which is 186.176.45.23, being a peer-to-peer connection with our customer side, which is 202.101.40.12, because public IP address talks to a public IP address. Although this 202.101.40.12 is eventually going to pass traffic to my voice business controller, which is 192.168.1.2. You understand it as we move on with the tutorial. So effectively what we are going to have is this IP address of this controller 192.168.1.2 talking to BTC through the firewall, and becoming this IP address through the internet right up to the BTC SBC, and it's going to signal to here. So this is our peer-to-peer connection that should be up. When this connection is there, then our trunk is up. So we are going to talk about the conditions that makes this peer connection to stay up, and we are also going to talk about signaling and so forth. Let me just clear things here for housekeeping. Okay, so on the firewall we are going to ask or request IT to do a port forwarding on the firewall. Here, this is the firewall. We want them to port forward port 5060. This is port 5060 to 192.168.1.2, which is the Mivoice Business controller. So they are going to port forward they are going to do a port forward on the firewall. Port forward the public IP address of the customer on the firewall, which is 202.101.40.12 port 5060. They are going to port forward it to my voice business controller on 192.168.1.2 port 5060, so that this port is in direct communication with this port, so that they are paired. Okay, I will remove that. I'm just using this new tool. It's giving me a headache to use, but just bear with me. It is what I have for now, until I manage to get a better tool. But for now we will use this tool. It will get the job done, do not worry. It just takes us a while, but until I can manage a better tool to use, we have to use this one. So now that port forwarding is in place, that's the policy to put on the firewall, policy number 1. We are going to talk about policy number 2 later on as we progress. I think we are going to talk about 3 or 4 firewall policies that need to be in place, but for now Let's continue. I'll give out the policies as we progress. So let's say I'll use blue this time. Okay, let me stick to red. I'll use that. Okay, I can use blue. Let's say this phone, it's probably its extension 2001. It wants to call a number that is on the PSTN, which is out there into the world. So I'll just say PSTN, and it is the BTC SIP Trunk that is going to connect us to the PSTN. Let's say the number that is sitting on the PSTN that we want to call is 3636466, and extension 201. It resides in this organization, in this company, and the company's telephone number, let's say, is 365. Okay, 365. Let's say 365 100. 36510. I'm just making up this number. If at all this is your number, it's by coincidence. I'm just making up this number. It's going to, the user is going to go off hook on this extension and dial some digits. Is going to dial 3636466 because that's the number they want to dial. Of course, probably they'll prefix a 0, or they'll put a independent account code, authorization code, and so forth, but we ignore that for now. We just talk of the final number that's going to go to the PSTN, to the BTC SIP Trunk. So the user is going to dial 3636. The user is going to dial 3636466, and the controller is, I'm also ignoring a lot of other things. The communication between the controller and the IP phone, when somebody wants to make a call, we'll just assume that all that is in place. So the controller is in turn going to send an invite to the BTC signaling IP address. We are going to have is going to send what we call an invite. This invite is three things. Number one, it has a to segment, and number two, it has a from, and number three, it has SDP options in it. So in the invite is going to, it's a to, which means it's directing this call to a certain number, which is 3636466. So in this invite, in the to, we expect the Mitel here on the Mitel side, when it is sending out to BTC, the information that is going to put in the SIP trunk is going to put an invite which says, I am inviting 3636466, which resides at 186.176.45.23, which is the BTC signaling IP address, and the port number is inside there, and the port number also here is 5060. This is happening between these ports, and it's going to say this is coming from, it's going to now put its number, this telephone number, the customer, it's this invite is coming from 365.100 at, on the Mivoice Business side, is going to put the IP address of the controller, which is 192.168.1.2. But because this IP address is a private IP address, it's a LAN IP address, once BTC sees this IP address, it cannot talk to it back. It's unroutable on the internet. So BTC should not see this IP address, although the Mivoice business has put it in. So it becomes the duty of the firewall here, using what we call SIP algorithm or SIP LG. It's going to inspect the packets that are going to BTC. When it sees this 192.168.1.2, is going to replace it with the public IP address of the firewall, which is the exit interface. Is going to replace this with 202.101.40.12, and of course the port is 5060 here. So as soon as BTC realizes that this is an invite which is coming from this IP address and this customer telephone number, it verifies in its database if it is allowed to peer with this IP address. Yes, it's allowed. Then it says, am I allowed to allow this telephone number through? Probably it checks the billing side and so forth. Then if everything is yes for the telephone number and yes for the public IP address, the call should start to signal and it should start to ring the destination, which is 3636466. It should start to ring there. But of course the BTC side will also send in a response to the invite, which is probably an OK. And also the third part that is happening in that same packet is that there is SDP options. All SDP options are meant to negotiate media. They are meant to agree between the two parts which port they are going to use for audio, which is media or RTP ports. So it is very important. Okay, let me just do a quick cleanup for now before we continue. I need to create space so that I can scribble some more notes here. I need to scribble here. So let me take another color perhaps. Let me look for another color. Let me take this purple. So we are now discussing the SDP options. So when Mitel is sending these SDP options in the invite, is going to say, I am inviting 186.176.45.23 to send audio to me to IP address 192.168.1.5, which is this IP phone which is making the call, and it's going to choose at random a port which is free from this port range. You see there's a port range here, 50,000 to 50,511. Let's just say for argument's sake it chooses the last port. It's going to say 50,511, and it's going to say, can you, this information is coming again from 202.101.40.12. Is going to say, when you have opened up media, BTC, when you have opened up media, send media to 192.168.1.5 on port 5511. And again, because this IP address, it's a private IP address, it's not routable over the internet, BTC should not see this number, because once the BTC sees this number, it has no way of sending packet to this, and we are going to have a scenario where we don't have audio, those audio packets will be lost. So again, it is the duty of the file using the SIP algorithm to change this IP address to the public IP address of the file, which is going to be 202.168.202.101.40.12 and this port number. So this is what the BTC side is going to see. It's going to see 202 for media. Then this SBC from BTC is going to respond in the invite OK message. Is going to, when it's sending back the invite OK message here, is going to agree to talk to this 202.101.40.12 on port 5051, and it's also going to say, but I want you, when you are talking back to me through media, use this IP address. Now it's going to send its media IP address 186.176.5.22, and it's also going to select a random port of any free ports. Its range is 10,001 up to 65,534. Let's say for this tutorial it chooses the last port. So it's in its invite OK message is going to say, talk to me on 186.176.176.45.22 and port 65534. This is the, so eventually we are going to end up with something like this. Again, I'll clean up the board. This is not a friendly tool for me to use, especially when I want to clean up. So what we are going to end up with is a negotiated media. We are going to end up with a negotiated media path. Media path between 202.101.40.12 on port 50511. This going to 186.176.45.22, which is the media IP address for BTC on port 65534. Then again, it is the duty of the firewall here to change this part, when it hits the LAN, when it is now moving from here onto the LAN, so that it can reach this phone. It should be able to change this to 192.168.1.5.50511, so that we end up with a complete audio path from this phone all the way to BTC, all the way to the other side where there is 3636466. If this doesn't happen, we are not going to have audio. So which brings us to another policy that we want to have on the file. We want the file to be able to allow this IP address of the media and these ports, this IP address, the one I'm marking with a star or an asterisk, and these ports, they should be allowed in to the network through the file. It should allow inbound traffic on these ports. Otherwise, if the firewall blocks these ports, there's not going to be audio. So it is very important to make sure I've got a firewall, or it could be a firewall, it could be a router, or whichever is managing the traffic between the LAN and the internet. You should be able to let those ports be able to allow the packets to come through, because you can appreciate that this is a peer-to-peer connection between this phone and this. So while it's this phone, we said is extension 2001, is still on this call with 3636466. Maybe this extension user 2002 also decides to make a call, probably to another number, like maybe 391.24.24. It's going to go through the same process, but it's also going to open its own media path. So eventually what we are going to have is another negotiated media, because we used 50511. Maybe it's going to negotiate it to say, for this particular call, okay, let me change the color for this one. I'll change it to yellow. So for the call that is going to happen in yellow to this number, we are going to use port probably 50510, and also the same IP address applies, 101.40.12. And on the BTC side, probably is also going to negotiate to say is going to talk back on 186.76.45.22 port 65533. So you can see we've got two paths going. So eventually what it means is that each and every phone if you have maybe 10 phones in the network and all 10 phones are on a call, we are going to have 10 different media paths going there. So this is not a supported way of operating SIP trunks on Mivoice Business by Mitel. It is not recommended. They recommend that you use a Mivoice Business border gateway. So an MBG's role is to proxy the media, so that all these phones will talk to the MBG, then the MBG is the only one which is going to talk to the outside world. And also this is going to anchor media. I think for now we end here, unless if there are questions you can send them in the comment section. I'll try and reply to every question or every suggestion. You are welcome to contact me through the comment section. And if you didn't understand anything, just hang in there. You may probably understand it in the next video when you actually get to doing this practically on the controller. But we are not going to be doing any firewall policies because we don't configure firewalls. But I hope at high level you've understood how a SIP trunk operates in terms of with BTC, in terms of connecting to BTC. Okay, thank you so much for watching. Until next time, bye bye.